Hi, my name is Wei Xiang, and these are my team members Sai and Miang. Yeah, okay. Today, we'll be presenting on our project on urban farming, focusing on efficient water use and higher crop yields. Next page. So I'll start with our driving questions and research funding. Then Sai will explain our solution and implementation. And finally, Mei Ang will go over the block diagrams and flowchart. Next page. So our project is guided by this question. How can we optimize water resources and improve productivity in Singapore urban farming through automation and environmental monitoring to address space and sustainability challenges? One major challenge is water scarcity. Water is essential for agriculture, but Singapore's small size and limited freshwater resources makes it a scarce resource. Currently, over 50% of Singapore water is imported from Malaysia, raising long-term sustainability concerns. Additionally, climate change has led to unpredictable rainfall and droughts, increasing the need for water-efficient farming systems. Unfortunately, traditional irrigation methods can waste up to 50% of water due to evaporation and inefficient distribution. Next slide. Another key issue is limited crop production. Singapore's land constraint and high cost makes large-scale farming difficult. Only 1% of our land is used for agriculture. This makes vertical and smart farming technology crucial for increasing production. Moreover, the high cost of water, electricity, and land make farming expensive. Fewer people are entering the agriculture sector, increasing the need for automation to reduce reliance on manual labor. Recognizing this, the government is investing in agri-tech and urban farming through the 30 by 30 initiative, which aims to produce 30% of Singapore's nutritional need locally by 2030. Now, Sai will explain our solution and implementation.
Okay, now I'll be introducing our smart urban farming system, an innovative solution designed to revolutionize agriculture. So there are three main features in our solution. A core feature on main and five stack to check moisture with 10 or 10 of model. On the second and five stack, we can check water level and adjust temperature depending on moisture value received from the main and five stack. And our core feature for main and five stack is automated moisture control. The functions of this feature is to ensure optimal soil moisture levels by automatically activating or deactivating the water model. Second feature is water level monitoring system, which is from second and five step. We can connect it with the Beton A. Its function is to display water level data on the dashboard for better water resource management. And last but not least, we have adjustable climate control feature, which is also from second and five stack connected with the button C. This will adjust farm temperature manually based on moisture data received from the main and five stack. Next. So uh, let's see what components do we use for the project. And now we have two and five stack, the main and five stack and secondary and five stack, and one art sensor and one servo motor and one environmental unit and one angle unit. And the last one is the power hub. Next. Uh, and then let's take a look at our solution in more details. Our system consists of three key features: an automated watering system, a water level monitoring system, and an adjustable climate control system. So let's take a closer look at how each component works. The automated watering system ensures plants receive the right amount of water at the right time. So we use an out sensor to measure soil moisture levels. When moisture levels drop below the required threshold, a servo motor is activated to regulate water flow, providing irrigation only when necessary. So this spot irrigation method prevents overwatering and conserves water efficiency. And the next one is the water level monitoring system. To maintain water availability, our system employs TOF sensor to monitor water tank levels. This real-time tracking system alerts when water levels are low, ensuring optimal water management without waste. And the last one is the adjustable climate control system. Our climate control system includes an environmental sensor to monitor temperature. Using this data, we can manually adjust the temperature conditions with an anger unit. The anger unit-based temperature control system allows us to regulate temperature manually. The system adapts based on plant moisture levels, like when soil moisture is high, the temperature is increased, and while moisture is low, the weather is too hot, like until the plants cannot even handle it, so we can reduce the temperature manually. So this balance ensures plant health while optimizing energy efficiency. With our smart urban farming system, we can make farming more efficient, sustainable, and productive, whether you're managing a small farm or a large scale plantation. So this system helps you save resources and maximize yield. And then Chen will present about the flow chart and the block diagram. Thank you.
Okay. I will be explaining the blow diagram of our Pfister-based project. At the center of our system is the main Pfister, which of as the core processing unit. It receives an input and control multiple outputs. So on the input side, we have an sensor connected to port P to measure the moisture level of the plants. And on the output side, we have a lot of components. We have sub motor to port A to 10 and 10 other like our irrigation system. And we have RGB bar to notify the user like our match height is low or high. And then we have advanced status for display, like to monitor and display the data. And then we also have our scan advice that using ESP to receive the data or the sensor. And then I will explain about the flow diagram or the scan advice that. So in this block diagram, we have the scan advisor microcontroller. So on the input side, an ATUF sensor for measuring water level and environmental sensor for getting current and temperature. So connected via PAHAV connecting to port A. And we have also an anger unit is connected to POV to enable manual temperature adjustment. And then we also have the main and five steps communicate with the microcontroller with ESP now for wireless data exchange. So on the opposite side, the RGB bar will provide visualization of the data collected. And then the advisor does go to play present real-time sensor readings and systems data for user monitoring. I will explain about the flowchart of the main advisor. Uh, in the main advisor, connecting to the scan advisor is the first process. After that, we'll get the moisture value from the sensor, and then uh, check the moisture value is less than minimum moisture. If yes, we will motor rotate to 180 degree, and then motor state 10 on, and then we show the moisture state low, and and then notifying the user using RGB bar and bar graph being read. If no moisture value is not like minimum moisture, we will check the moisture value is higher than maximum moisture. If yes, uh, model rotate to 0 degree and model state will be 10 or and moisture state will be high, and then RGB bar and bar graph will be below. If not, we assure that moisture will be normal. So we will stay 10 of the motor and motor rotate to 0 degree and moisture state will be normal. And then RGB bar and bar graph will be green. After that, like moisture value, moisture stated, moisture was, and motor state will be displayed on the file status bar. The final process is the sending the moisture value to the scan and file state by ESP now. And then there's the flowchart of the scan and file state. In the canary and Pfizer, there are two features like checking water level and manual temperature control. So if you press button A, uh, checking water level function will be processed, and if you press button C, manual temperature control function will be processed. So let me explain the details of the two functions. So firstly, checking water level function. So getting water level from TOF unit is the first process. So if water level is less than 2 cm, uh, water state will be low, and then RGB bar will be red to notify that water level is low. If not, water status will be normal and the RGB bar will be green. So the final step is like water level and water status and water graph will be shown on the main FI status bar. So after that, let me explain about the manual temperature control function. So firstly, get the Angle value or 0 to 20 from Angle unit, and then we will set the current Angle value to the Angle value from the Angle unit, and then we set the previous Angle value to the 10 as a default mode. So and then like we will set the angle to like the substituting the previous angle from the current angle. So if the changing angle data is not equal to 0, we will add the data value to the current temperature, and then we will memorize that the previous angle as a current angle. So after that, we'll check the moisture value also. If moisture is less than minimum value, so we will set the notification like moisture low to decrease the temperature, and then we should also like if current temperature also manual stay less than manual temperature, we will stay notifying that like moisture low and to decrease temperature. If not, we will change the notification to like temperature okay with moisture. And then if moisture is not less than minimum, we will check moisture value is higher than maximum. If yes, we set the notification to moisture had an increased temperature, and then checking also like current temperature is higher than manual temperature. If yes, now temperature okay with moisture. If not, stay notify the users like moisture stay high and to increase the temperature. So if not, and then we sure that moisture is normal. Yeah, after that, I show all the relevant data on the circuit. Yeah, that's all about our flowchart. And then let's see our live demonstration or the demo.
Hello, I'm Sai. Now we're doing the prototype for demonstration. So I demonstrate for the moisture, the main feature. So firstly, the moisture is high. So and then the RGB bar will turn blue because of the high moisture indicator. So at the time the motor will turn off to avoid the excessive hydration. Okay, right now the moisture is normal. So that the RGB bar will turn green, and then the motor status also turn off like the quantum moisture is high. So we'll just indicate the like optimal moisture, so we can conserve water and prevent overwatering. And then the last one, when the moisture is low, the motor will turn on, and the water will flow on here. So how we can water the plant and ensure the sufficient moisture for higher productivity. Then so the RGB bar will turn red because of the low moisture warning. So the water will flow here. So when I put down, the moisture will turn like into high moisture status high. So that is for the moisture feature. Okay, thank you.
Now I'll be showing our second feature, which is to monitor the water level. So if I press the button here, it will show the water level, and if it's normal, about 5 cm, it will show a green LED, as you can see, normal water. Okay, so now the water level is low, and it will show through the status as well as the LED turning red.
Hello, my name is Channel. I will be presenting our last feature, adjust the temperature with the moisture received from the main and FI stat. So to adjust the temperature, we need to press the button C in a scan and FI stat. So when we press the button C, you see the moisture is high, and then now the rated temperature is higher than the current fan temperature. So the temperature okay with the moisture, and then all the main and FI stat also moisture high. So we have to receive the data or moisture data from the main and FI stat by using ESP-NOR. So when I adjust the temperature lower using Angle units, so it will change like it will notify you to increase the temperature because moisture is very high. When the temperature is high, so it will affect the plant growth. Okay, so when adjust the temperature higher, it will change like temperature okay with moisture. So for the main FI stat, the moisture is low. So on the scan and finds that also moisture low. So we need to decrease the temperature lower than the current temperature. So I will decrease the temperature. So you see, when the temperature at manual elevator temperature is 22, lower than 24 degrees current temperature. So it will say temperature okay with moisture, and then the temperature will also show the status, and then the RGB will also show the status. It's okay. So when I adjust the temperatures to be higher, it will notify like decrease the temperature. So I need to lower down the temperature by using NK units, and so it will lower down temperature okay with moisture. So I use the adjustment the moisture with temperature, so it will save our energy. Yeah, that's why we call sustainable urban farming. Thank you.
Okay, thank you.
Thank you.
Thank you.